Hi everyone, this is Mrs. Van Horn, and this is the third and last video recording of the lesson of week 4 of IM1 distance learning. Now that we are very familiar with how to graph the solutions to systems of inequalities, we are going to try to solve some application problems that involve the systems of inequalities. So here I have a problem, okay? Jana is buying a peanut butter cookies and chocolate chip cookies for her friends. She needs to buy at least 15 cookies. Peanut butter cookies cost $2 each and chocolate chip cookies cost $3 each. Jana can spend at most $45. Okay, so the first thing we do when we see a word problem or application problem is see if we can pull it apart, because there are a whole lot of words, a whole lot of information, and we don't know which is important and what's going to be really helpful. So we're dealing with baking or buying chocolate chip cookies and peanut butter cookies. Yum! So peanut butter cookies cost $2, so I am just going to highlight this. And chocolate chip cookies cost $3 each. And Jana can spend at most $45. Okay, so we have some cost here. Chocolate chip peanut butter cookies $2, chocolate chip cookies $3 each, and Jana can spend at most $45. And the challenging part is putting that information in English into mathematical inequality or equations. So find at least 3 possible combinations of peanut butter and chocolate chip cookies that Janet can buy. So we're going to start by defining our variables. What is it that we do not know? It gives you a clue here. 3 possible combinations of peanut butter and chocolate chip cookies that Janet can buy. So is it the cost of the peanut butter cookie and chocolate chip cookie? No, we already know that. So it's not that. It's not the cost. It's really how many she can buy. So let's let X be the number of peanut butter cookies. That Jenny buys. And Y then becomes number of chocolate chip cookies. I love chocolate chip cookies. Okay, but then again, I love peanut butter cookies too. How to decide? Okay, so write 2 inequalities in standard form. Okay, so we are given this information and we have to turn that into inequality. Let's deal with what I highlighted in red. Peanut butter cookies cost $2 each, and chocolate chip cookies cost $3. So, and what else do we know about this? Okay, so we are also given that she needs to buy at least 15 cookies. Maybe I should have highlighted that in different colors. Okay, so that will be a different colors. That's another information that is key that we did not point out. Okay, so how many cookies? She needs to buy at least 15 cookies. That means if X is the number of cookies that peanut butter cookies she buys, and Y is the number of chocolate chip cookies she buys, what will be the expression that total number of cookies that she buys? That will be just X, because that's the number of cookies, peanut butter cookies that she buys, and Y will be the number of chocolate chip cookies she buys, and we want that to be at least 15 cookies. Okay, so let's think about the word at least. What does at least mean? Can she buy 5 cookies? Would that satisfy at least 15 cookies? No, that's not enough, is it? Okay, can she buy 10 cookies? No, that's still not enough. Can she buy 15 cookies? Does that mean she bought at least 15 cookies? Yes, if she buys 15 cookies, so she can buy 15. If she buys 16 cookies, is that at least 15 cookies? Yes. So that means that X plus Y, the number has to be bigger or the same as 15. Okay, so that's my expression for the total number of cookies. But now let's talk about the cost. Okay, the cost is all of this information. It costs $2 and we're buying X number of $2 cookie and we're buying Y numbers of $3 cookie. So how much would it cost altogether? It will be 2 times X number of peanut butter cookies, because each one of the cookies, a peanut butter cookie, costs $2 and I am buying X number of cookies, and number of chocolate chip cookies, I am buying Y number and each of them costs $3, and she can spend at most $45. That means, can she spend $45? Yes, she can. So it's somehow equal to. Can she spend $47? No, she cannot, because that goes over. Can she buy $40 worth? Yes, that's okay. So that means this is less than or equal to. Okay, so we've come up with two inequalities. And it says here, change the above inequalities into intercept form. Well, they're doing that because it will make it easy for us to graph the solution. Yes, we can do that. Well, we don't have to do that, but let's do that anyway. Okay, so total cookies, I am doing it in blue. So that is going to be, we just want to solve for y. That means we don't want the x. So we're going to subtract x from both sides. So we are starting with x plus y is greater than or equal to 15. From here, I am going to subtract x, which leaves me with y is greater than or equal to negative x plus 15. Now it's a linear inequality. Okay, what about the total cost? We have 2x plus 3y is less than or equal to 45. So that means we want to get rid of this 2x first. Okay, and then that will leave us with 3y is less than or equal to negative 2x plus 45. And then from here, we want to divide both sides by 3. That means everything by 3, which leaves us with the inequality y is less than or equal to negative 2 over 3x plus, what's 45 divided by 3? Okay, how many 3's goes into 40? Oh, that's going to be, so 30 will be 10. And then 15 divided by 3 will be 5. So 15. Okay, so then I am going to start to graph it. And to do that, we need to mark our x and y axis. Okay, so x we said was, what did we say x was? X was the number of peanut butter cookies. So x is number of peanut butter cookies okay, and then y is the number of chocolate chip cookies. So y is number of chocolate chip cookies. Okay, all right, so it's blurry right now because I moved it around. Okay, let's try that. Good. Okay, so then we have to find the y-intercept. Okay, so we need to put some numbers in. I am going to go by 2's. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So obviously you don't have these notes. So you should be taking these notes down on your notebook. Same thing, I am going to do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. Alright, so then let's graph the first inequality. Y is greater than or equal to negative x plus 15. So y-intercept is 15, so find my 15 here. And the slope of negative 1, that means go down by 1 to the right by 1. Down by 1, right by 1. And I will get my graph. Okay, so is this going to be a solid line or dashed line? It should be a solid line because of the equals inequality. Okay, and y is greater than. Y is greater than, that means I am going to be shading above. Okay, alright, then let's do the next inequality. Y is less than or equal to negative 2/3 over x plus 15. So we have 15 again. This time the slope is negative 2 to the right by 3. So negative 2, right by 3, negative 2, right by 3, so on. Okay, and again, this is going to be straight line. Okay, but this time, the inequality says it's y is less than or equal to. That means I am shading this side. Okay, then which was the area that satisfied both the inequalities? It's over here. So that's my solution area. Okay. Alright, so I figure out my solution area. Now we have to list 3 xy pairs that are possible, because we just discovered that any point xy combination in this area will be possible. Prove that these xy pairs work in both inequalities by plugging them into original inequalities. So let's make it easy. Let's choose an easy number like 10 and 7. Okay, let's choose that. Say 10 and 7, comma 7. So if I choose 10, comma 7, well, according to my graph, this is a solution area. That means this is number of, this is x and this is my y. Let's put that into the first inequality. That will be x plus y is greater than 15. So that will be x 10 plus 7 is greater than 15. Is that true? 10 plus 7 is 17, greater than 15. This is true. Okay, and that was 2x plus y is greater than or equal to 15. Okay, it's always a good idea to check against the original inequality. The second inequality was 2x plus 3y is less than or equal to 45. So 2x is 2 times x is 10 plus 3 times y is 7 is less than or equal to 45. Let's simplify this. That's 20 plus 3 times 7 is 21 is less than or equal to 45. 20 plus 21 is 41. Is that less than $45? Less than or equal to $45? Yes, it is true. So it satisfied both inequalities. Okay, all right, so, and let's do just one more. Okay, let's pick another point. Okay, so how about 12 and 3? 12 and 3, this will be another point. 12 and 3. Okay, so you could have picked any combination. So if I pick 12 and 3, then the first inequality say x plus y is greater than or equal to 15. 12 plus 3, is that greater than or equal to 15? Yes, because that is 15 is greater than or equal to, they're actually equal to each other, but that is still true because equal is a valid thing. Okay, all right, so then let's do the other inequality. The other inequality say 2x plus 3y is less than or equal to 45. Okay, so that's 2 times x is 12 plus 3 times y is 3 is less than 45. 2 times 12 is 24. plus 3 times 3